Alright, this is a video lesson for Unit 5, Lesson 1, which is talking about scatter plots and lines of best fit. So what a scatter plot is it's a graph that isn't necessarily a line or a perfect rule. So when you're talking about a rule, you're talking about something that looks like this, where every point is perfectly on a line. So every ordered pair is nicely on the line. You're going to see that for every single point. Okay, that's not really what we're dealing with in this lesson. Instead, we're dealing with some real-world data where you're noticing trends amongst the data. So like they move in a general pattern, but they're not fit to a rule where it's automatic and you know exactly what every ordered pair is going to be. Instead, we're going to look at trends and try to make a prediction line, which is what a line of best fit is. So I'm going to start off by getting this data onto this graph. So we're going to let time be the label for our x-axis and temperature be the label for our y-axis. This is like after 1 hour, after 3 hours, after 5 hours. So we can start at 0 for time. So time, we're going to start at 0. I'm going to go every other to space it out. 3, 4, 5, 6, 7. You might think we could stop at 7, but they're going to ask us in a minute to make a prediction at 9. So I'm going to keep going, give myself a little bit more space so I can kind of see what's going on there at 9. Now, as far as the temperature goes, it looks like the trend is that the temperature is going downward as time is going down. We see 66, then 63, then 57, then 53. It's going down. So I'm going to assume that I'll be okay starting my graph at about 66 height. So I'm going to do that up here. And because we're not going to get, it doesn't look like it's going drastically down and we're just going 2 more hours, I don't think we're going to make it all the way down to 0. So I'm just going to tick off from 66. So 66, 65, 64, I'm going even. 63, 62, 61, 60, 59, 58, 57, 56, 55, 54, 53, 52, 51, 50, 49, 48, and then I'm just going to do this little scribble mark here that just shows that we're not making it all the way down to 0. We're just kind of zooming in at one part of the y-axis. So we're going to plot these points. We're going to go to 1 o'clock and plot a 66. 166. So this says that after 1 hour, the temperature was 66 degrees. Now, again, this isn't a rule, it's just an observation. So sometimes when you see a scatter plot, you might actually see a couple of different points on the same time because maybe we're reading the temperature in 2 different places. But for this one, we just know that at 1 o'clock there's a 66. At 3 o'clock there's a 63. At 5 o'clock there's a 57. It's a lot of dots, so I'm trying to be careful here. 5 o'clock, 57. 7 o'clock, 53. And now, if you were trying to draw a line through all of these, if I was drawing through these two, it wouldn't get through all the dots. If I got through this one, it'd get through 2 of them, but it's not going to be perfect. And that's the point. It's not supposed to be perfect. But I'm going to take a little thin line here, and I'm going to go through some of these points to kind of give myself a rough idea of where this pattern is going. These points are pretty close to this line, which is going to be one of our vocab minutes in a minute, vocab words in a minute, line of best fit. So this is kind of giving me an idea of what's going on. So now when they ask me to make a prediction about what's going on at 9, I'm going to look at that trend line. And at 9, it's looking like my pattern is taking me around 48, 49 degrees. Either one of those would be accepted. So we're just kind of making a prediction based on what the other data values look like. So a line of best fit or trend line can be found for a given set of data if there exists some kind of correlation. Not everything has a perfect correlation, but when you can see it, you can use that to make predictions about future points. So for this, we're going to learn about 3 vocab words. One is positive correlation, one is negative correlation, and one is negative correlation. Think slope man here. Positive correlation will be a positive line. Negative correlation will be a negative line. No correlation is going to be crazy. It's going to be all over the place, and you're not going to be able to see any kind of pattern. So for number 2, this first line, I could reasonably draw a little line right through these, and that's a negative line. So this is a negative correlation. For this one, I could draw a line through it, and it's a positive correlation. It's a positive line that would go through it. No line looks good here. I don't really see a distinct pattern how the points are moving, so this has no correlation. You can pause and try the next 3 if you think you're ready. Alright, so this next one, I can see a little positive line going through those. And this next one, I don't see it. I kind of see a U going through them, but that's neither a positive or a negative. So I'm going to say no correlation. No linear correlation to be specific. No correlation. Okay? And then this last one, I see a negative line going through it. So I would say a negative correlation. That's all they wanted us to do, just identify. All right, so new problem. You're studying the way that a tadpole turns into a frog. You collect data to make this table. So we're gonna let age be our x and length be our y. It looks like I need to get up to 10 days, so I'm just gonna space this by ones. 0, 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days, 8 days, 9 days, 10 days. I might have been able to fit more, but I think that'll be okay. And now for length, we need to get up to 14. Well, I can tell that this grid's about 20 tall, so I'm just going to go by ones on this too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'm going to go all the way because we might see the pattern extend beyond our points. So we'll label this all the way up to 20. So at day 5, we've got 14. So 5 and 14. Be careful here to be accurate. 2, 15. I'm just taking these ordered pairs and putting them on the graph. So 2 and 15. 9 and 3, way down here. 7 and 8. 4 and 12.5. 12.5 is going to be between 12 and 13. 10 and 3. 3 and 12. 6 and 9.5, which is going to be between 9 and 10. So you see, definitely not a line, but it's heading in a general path. I'm just going to take a line and kind of try to cut these points in half. I think that line does a good enough job of that. And this is what I would call my line of best fit. We'll learn later how to do this a little bit more technically, but this is a great way to get an idea of where this data is heading. So first they say, does the data have a positive, negative, or no correlation? Well, I would say that it has no correlation. Oh, sorry, not no, negative correlation. This would have a negative correlation. Then they ask us to draw the line of best fit using 2 of the points. So here's my trick for this. I'm going to do what we did last unit, which is writing the equation of a line. I've got this line that looks like it's going through about 1, 2, 3, maybe a fourth of the points on my graph. So I'm going to go and steal 2 of those points and write an equation. Well, the thing I really don't like about this is 2 of my points are kind of like the 0.5s, and that's ugly numbers. So I'm going to adjust my line of best fit just a little bit, and we're going to delete it. And I'm going to pick 2 nice points for it to go through. So I'm going to pick this point here, 215, and then I think I'm going to put it through that 10.3. I think that does a really good job of describing the data. And now it gives me 2 nice points to use, 215 and 10.3. Well, my slope, I'm going down here 12, and I'm going over 8. So my slope is negative 12 over 8. So we're going to start writing that. My slope is negative 12 over 8, which can be cleaned up into being negative 3 over 2. We'll pick either one of these points. I'll do the 215. And we're going to write the equation of this line, and that's how we'll find the equation of our line of best fit. So to do that, we use point slope, just like last unit. Y minus 15 equals the slope, negative 3 halves, x minus 2. And we'll go from there, and I'll get y minus 15 equals negative 3 halves x plus 3. And then I'll add the 15, and we'll get a final equation here. Once I shrink this up, we'll get a final equation of y equals negative 3 halves x plus 18. And that's our equation. Now they ask us to use this equation to predict the length of the tail of an 8-day-old tadpole. Well, age is our x. So when they want 8 days, they're telling us x equals 8. And we have an equation right here that we could use to make predictions. It's another name for a line of best fit is a prediction equation. So we're going to take that equation, y equals negative 3 halves times x, which we're going to put 8 in for, plus 18. And that ends up being negative 12 plus 18, which is 6. Now, a moment of quality control. Maybe I messed up there. Let's find out. Let's look at that xy. Let's look at 8, comma 6. Does this seem to make a little bit of sense? 8, 6? Yeah, that looks like it would fall right on the line. So that's a reasonable answer. And that is our answer. We would predict the length to be 6 millimeters by plugging into that equation. Then they ask us to determine when the tadpole would have no tail. Well, that is telling us the tail length is 0, so when y equals 0. Well, we have this equation up here, and we're going to take it, and we're going to plug 0 in for y. 0 equals negative 3 halves x plus 18. I'll subtract 18 from both sides. We'll get negative 18 equals negative 3 halves x. I'm going to multiply both sides by the reciprocal, so 2 over negative 3 to get rid of the negative 2/3. I'll multiply this side by the same thing, 2 over negative 3. And that ends up being positive 12. So x equals 12, and that's an x, which is age, 12 days. So we utilize the equation to be able to do this. All right, so now we have a few more notes that they're going to have us do. The first one says, does there appear to be a correlation here? I want you to try these problems at this point and then check my answers afterwards. So I would say that there looks like there's a definite positive correlation here. So I'm going to say positive. There's a positive correlation between shoe size and score on the reading test. They ask, so the first question was just asking, is there a correlation? So do you see anything? And I would say yes, there's definitely a correlation. And we're seeing that it's a positive correlation. And then C says, What reason could there be to see a correlation like this? Do you really think people with bigger feet are smarter or able to read better? And another correlation that you might realize, or a cause for why this would be happening, would be the fact that the older you are, the larger your shoe size. So you get smarter as you get older and your shoes get bigger. So it makes it seem like somebody might interpret this table as saying, oh, people with bigger feet have higher reading scores. But that's just because they're getting older. So explain why it's not reasonable to conclude that people have or big feet causes a higher reading score. I would say not necessarily true. The people with bigger feet might be older, making them smarter. As well. So that's a better explanation for why we're seeing this correlation than saying, well, big feet make you smart, which isn't necessarily true. Now we've got another one. And this one talks about the value of a car based on how old it is. Is there a relationship? Yeah. It's linear. I can see a negative line definitely fitting through it. Yeah, there's some points that don't seem like they perfectly fit it, but the vast majority of points would fit this line. They ask us, does this have a negative or positive? It's a negative correlation. They ask us, do you notice any point that might be considered an outlier? And that was that point that I identified right away. That 10-year-old car that's only worth about $4,000. The 10-year-old car is only worth $4,000. But that might not necessarily be about age. That might be a car that just got really poor care, or somebody was just willing to part with their car for a lot less for whatever reason. So that just because there's one outlier doesn't mean that the relationship in general isn't true. Couple more questions to wrap up here. Okay. Scientists are interested in finding out how many different species or how different species adapt to finding food sources. So we have some different graphs showing body mass versus the bite force of these crocodiles. So the first question says, describe the relationship between body mass and bite force for the crocodiles shown in the scatter plot. Well, in any one of these, just so you know, the data is the same in all these pictures, but Taylor, Patty, Sol, and Marissa, they all drew their lines differently. But regardless of how you draw your line, it's pretty obvious that all of these are positive. Positive relationships. Positive relationship. And what that means is, as the crocodile gets bigger, the force increases. As X improves, so does Y. Then they said, for each student, indicate whether or not you think the line of best fit would be good to use. So if I look at this, here's how we judge a line of best fit. We want to see about half the points below and about half the points above the line. So when I look at Marissa's, this one would be unacceptable. Marissa's is unacceptable because she has too many points below. All points are below the line. So that's unacceptable. That's not something that we want to have. If I look at Patty's, looks like there's a lot more points above than below, but it's not terrible, but I definitely wouldn't call that one the best. When I look at Taylor's and Sol's, it's looking relatively even in terms of the number of points. So I could hear the argument for either one, but personally, I think I would say that Taylor's is probably the best. I think, yeah, she might have a few more points on top than bottom, but it just looks like it's a pretty even split for the points. So my argument would be Taylor, but I think all three of those ones are good. Really, it's Marissa's that is the bad one. Number 4, a couple of quick questions here because they're just talking about the relationship between positive and negative and what they mean. Okay, so here's the thing when you see positive. Now I'm going to draw it down here. Positive. A positive relationship looks like this. And what you'll notice is as x increases, so does y. As x goes up, y goes up. If you wanted to think about it in reverse, as x goes down or to the left, so does y. Y goes down too. So as x goes down, y goes down. So what you'll notice about these is direction are the same. Up, up, down, down. Now let's look at negative. On a negative line, for a negative relationship, as x goes up, y goes down. So as x goes up, y goes down. On the flip side, as x goes to the left, as x goes down to the left, y goes up. So what you'll notice for this is the directions are opposite. So we're going to look for that in words. So in 4 it says on average the more flowers, the less bees. More and less, that's opposites. And we're looking for a positive correlation. So more or less, nope, that's opposites. We want same. Less flowers, less bees, that means positive. So B works. On average, the more, we like that. That's also positive. For D, less, more, not going to work. Opposites. On average, the number of bees will be the same. That doesn't make any sense. That wouldn't be a good growth relationship, a positive relationship. So B and C would represent a positive relationship. For 5, if there's a negative relationship, what must be true? Which of these can we conclude? More, that's same. If it's negative, we're looking for opposite. More, less, that works. That's a negative relationship. Less, nope. That's same. Less, more, that's opposite. Nothing's changing. No, that's not it. So B and D would both work. It's a long lesson, but it's an important one, and that's the end.